What is up, good people? Welcome to section 2.8, equations reducible to quadratic. What that means, reducible, means that these are going to be all equations that are going to be basically as difficult as solving a quadratic equation. Let me show you what that means. Here we got x plus square root of x minus 12 equals 0. I'm going to make a u substitution. I'm going to let u equal square root of x. And as a strategy, it's also a good idea to figure out what u squared is equal to, because in this case, u squared is equal to x, because you're squaring both sides. When I make that u substitution, you can see that if I rewrite the original equation, it turns into u squared plus u minus 12 equals 0, which is something that you can factor. What two numbers multiply up to 12 and add up to positive 1? That's going to be 4 and negative 3. So you rewrite it as u plus 4 times, whatever at x, I'll change that, u minus 3. And then you have to solve the equation, u plus 4 equals 0, and u minus 3 is equal to 0. U is equal to negative 4, and u is equal to positive 3. Now, back substituting. What does u equal in the first place? It equals the square root of x. So, let's figure out what x should be. Rewriting the solutions in terms of the square root of x equals negative 4, because u equals square root of x, and square root of x equals positive 3. Now, let's square both sides, like we learned how to do last section. When you square both sides, that's fine and totally legal, but you have to make sure you check your answers, because it might introduce solutions that are not actual solutions. X is equal to 16, or x is equal to 9. Let's check these solutions. Is 16 plus a square root of 16 minus 12, is that equal to 0? Well, if you take the square root of 16, then that would be 16 plus 4 minus 12 is equal to 0, which is not true. So therefore, x equals 16 is not a solution. Let's check to see if 9 is an actual solution. 9 plus the square root of 9 minus 12 is equal to 0. Well, that's just 9 plus 3 minus 12 is equal to 0, and that is true. 9 plus 3 is 12, minus 12 is equal to 0. So yes, x equals 9 is a solution. And it's the only solution. Let's jump over to number 2. I was thinking of doing these out of order, but we might as well just do them in numerical order. Okay, so we've got 2x to the fourth minus 10x squared plus 11 equals 0. Now notice that just if you make the u substitution of u is equal to x squared, all of a sudden this turns into a quadratic equation. Of course, u squared is equal to x to the fourth. 2 times u squared minus 10u plus 11 is equal to 0. You can use a variety of methods to solve this, but the fastest is going to be probably the quadratic formula. A equals 2, b equals negative 10, c equals 11. So therefore, after you do all the simplifying for the quadratic formula, you should get something like 5 plus or minus the square root of 3 all over 2. Now let's back substitute, because really we're solving this equation for x. X squared is equal to 5 plus or minus the square root of 3 all over 2. And then to cancel out the 2, we have to take the square root of both sides. Now when you take the square root of both sides, you have to remember you have to introduce a plus or minus. So x could equal plus or minus the square root of that ugly fraction, the whole thing. 5 plus or minus the square root of 3 all over 2. So we've got two different plus or minuses here. That really means that there's 4 potential solutions, depending on how you choose the plus or the minus. You could actually run this through a calculator 4 different ways and get a crazy long decimal. You could do the plus plus, You could choose plus plus or plus minus, minus plus, or minus minus. And depending on your choice, you'll get different decimal answers, all of which you have to check. Checking with the calculator is not that bad, especially if you know some calculator tricks. But you're going to get crazy, so you have to check those decimals. We're not going to do that here. It'll be a kind of a longer video, but I'll just let you know that all four of them work. Okay, so the first step really is recognizing that if we make a u substitution, this could look like a quadratic equation. So really, the strategy here is to let u be the variable part of the b term. Now the b term here is going to be x squared minus 1. It shows up in the middle term, and it gets squared in the first term. It's a good idea to make sure you write out what u squared is. In this case, it's the quantity x squared minus 1 squared. So we get u squared minus u minus 2 equals 0. Awesome. This is something we can factor. What two numbers multiply up to negative 2 and add up to negative 1? That would be negative 2 and positive 1. So we rewrite it as u minus 2 times u plus 1 is equal to 0. I'm going to do the back substitution right now. Might as well. We get x squared minus 1. That's what u is, and then minus 2 from the factored equation. We get x squared minus 1. That's what u is, plus 1 equals 0. And now you see we can cancel some things. And we can combine some like terms. That just turns into x squared minus 3 equals 0, or x squared, because those cancel, is equal to 0. And if we solve these, we get x is equal to 0. And if you solve the first one, you get x squared is equal to 3, or x is equal to plus or minus the square root of 3. Now if we check these solutions, we find that x equals 0 does not actually work. So there's two solutions here, the square root of 3 plus or minus the square root of 3. Again, I didn't show you the check because I kind of wanted to shorten the video, but you when you do your assignment, you will have to check the video. Here, the variable part of the b term is t to the 1/3, so that's what u is going to equal. When you square it, you get t to the 2/3. That's 1/3 times 2. Making our u substitutions, u squared minus 3u minus 10 is equal to 0, which you can factor. What two numbers multiply up to negative 10 and add up to negative 3? That would be negative 5 and 2. So therefore, u minus 5 times u plus 2 is going to equal 0. I'm going to split it up now. U minus 5 equals 0, or u plus 2 equals 0. I'm not going to do the back substitution just yet. That means u equals 5, or u equals negative 2. What does u equal in the first place? It equals t to the 1/3. So t to the 1/3 is equal to 5, or t to the 1/3 is equal to negative 2. Alright, let's cube both sides of both equations to get rid of the 1/3 exponent. Then you get t is equal to 125, or t is equal to negative 8. You have to check both of these solutions. Maybe one of them won't work. But when you check them, you find that both of them our solutions. Next, here this looks like it could be, oh yeah, another u substitution, letting the variable part of the b term be the u. So u is equal to x squared, and therefore u squared is going to equal u to the fourth. So that means we get u squared plus 5u minus 36 is equal to 0. When you factor this, you have to ask yourself what two numbers multiplied to negative 36 and add up to 5. That's negative 9 and positive 9 and negative 4. So u plus 9 times u minus 4 is equal to 0. Splitting it up, we get u plus 9 is equal to 0, or u minus 4 is equal to 0. Solving for u, we get u could equal negative 9, or u could equal positive 4. Now what did u equal in the first place? U was equal to x squared. So therefore x squared could equal negative 9, or x squared could equal positive 4. Taking the square root of both sides is easier over on the right-hand side. That's plus or minus 2. X could be plus 2 or negative 2. Taking the square root of both sides over here is a little trickier, but we should be equipped to handle it. It's plus or minus 3i, because it's negative 9. And if you check all of these solutions, they all work in the original. Problem number 6. An object is dropped into a well. In 5 seconds, the sound of the splash reaches the top of the well. If we assume that the speed of sound is 1,100 feet per second, how deep is the well? I'm going to draw a little picture to help me out here. There's someone at the top of a well. There's some water down there. Can we get some color? Yeah. Color that water. Great. So a person is going to drop the object into the well from the very top all the way down to the bottom of where the water is. And then the echo is going to travel back up. Sound is not instantaneous. It actually has to travel at 1,100 feet per second. So it's going to take a little bit of time for the object to drop, but then it's also going to take a tiny fraction of amount of time for the sound to continue as well. Both of those times should add up to 5 seconds. There's a total of 5 seconds. We also know that the velocity of sound is 1,100 feet per second. What else do we know? Not much. We know that the object is dropped also. We're trying to find the distance. How deep, the depth of the well. From the ground level all the way down to the water level. Now, it might be helpful for us to introduce two more variables too. T of the time the object it takes to fall, and the time the sound takes to travel up. But remember, the depth is really our main unknown, and that's what we're looking for. So the relationship between TO and TS is the time the object it takes to fall plus the time the sound it takes to travel back up. And when you add those two together, you get the total time, which is T. We also know that V0 is 0 feet per second because the object gets dropped. So it doesn't start out getting thrown down, it starts out with a 0 velocity. So I'm going to write the distance equation that we have for an object being dropped. That's 16t squared. It's 16 because we're using feet. So 16t squared plus V0t. S is really, in our case, just going to be d. And to the t, which t are we using? We're talking about t object, the time it takes for the object to drop all the way down the well. V0 term just cancels out, so if you solve for t0, you get the square root of d over 16. Now that might be plus or minus, except you can't have a negative time, so we're just going to use the positive root, which is the square root of d over 16. Great. Then when it comes to sound, the sound is not going to accelerate upwards, it's not going to slow down, it's just going to be a constant rate. So that means that d, the depth of the well, is equal to 1,100
feet per second times the time it takes for sound to travel up. When you solve for that, you get d over 1100 is equal to ts. So now we have an expression for to and ts in terms of d. So I'm going to take that to plus ts equals t, and I'm going to fill in what we know. To is no longer to, it's square root of d over 16, or square root of d over 4, if you simplify it. Plus d over 1100, that's what used to be ts. And the total time, it's given that it's 5 seconds. Now here's an equation that is reducible to quadratic. If we clear the fraction by multiplying by the least common denominator, that's 1100, we'll just multiply all the terms by 1100. We get d, that gets cleared. We get 5500, and we get 275 times the square root of d. This is definitely reducible to quadratic. We've seen this kind of thing before. If solving an equation that has root d and regular d, I'm just going to rewrite the terms up here so that it looks a bit more familiar. Bringing the 550 over to the other side, setting it all equal to 0, that's what we get. Making a u substitution, u can equal the square root of d. And if we choose u to be that, then u squared would therefore have to be d. Alright, the new equation written in terms of u is u squared plus 275 u minus 550 is equal to 0. So, no way we're going to factor this one. A equals 1, B equals 275, and C equals 550, negative 550. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a yields that u should equal 18 plus 7.25. So therefore the square root of d is equal to 18.725. Again, I'm ignoring the negative because we're looking for positive answers. D is equal to, therefore, when you square both sides, about 351 feet. That, my friends, is your answer. So, with all that said, go ahead and begin 2H. That means you should copy the problem list into your composition book and do the first problem. Take care, and I will see you tomorrow in class.